much now. Cool. It seems to be working. Cool. The stream is live now. Sweet. I want to keep playing it in the window. Yeah, cool. Right. So the first thing I want to do is show you guys Git Kraken. So why do I want to show Git Kraken? Well, because I just found out a bug, right? So, wait, let me actually show you the bug first, right? So if you guys joined in last stream, right, you guys know that I worked on adding texture support. Oh, no. Oh, I'm loading in the cow, never mind. My stream isn't cooperating, give me a second. Right, or OBS I should say. No, moving the wrong windows. No. Sorry, right, I'm just trying to move the cow back to the corner, so it's not in the way completely, right? So that's now out of the way. Right, so I need to switch this to a different model. This needs to be assets potato slash potato Bvh. Right, I think it's like this. So what was the issue, right? Render. So right, textures. Oh, yeah, no way, sorry. I was testing some other things, so I didn't apply the texture here. So that is cow1 dot model data dot loaded in material, and this is, I think, the reference, right? Cool. Attempt number 2. Retreat to show you the issue that we were having. Right, so now we can see that, hey, we suddenly have the potato texture. So what in the end was wrong, right? Let me show you when the issue started occurring. So if I reapply the transform that we made last stream, I think, as well, we can suddenly see that, right, the textures are messed up. But once it does a full rotation, we can see the texture very briefly just reappearing. So I know actually what the issue is. It's basically the intersection point is wrong. So because the transform, we move the intersection point, however, we never put it back correctly where it should be. So shading and texture calculations are wrong. So we're basically adding UV coordinates that are illegal, giving us weird results. For some reason, this magically doesn't cause issues, but this could simply be due to clamping. So that's the issue. So that's what I want to show in Git Kraken to add the bug card. So fix the Bvh, or fix the issue with transforms causing the wrong intersection point, right? And this will be labeled with bug. And I think we might be able to, no, okay, this is fine. We just simply say it's a bug. I don't think we have to do anything else. This is actually not currently what I want to work on. So some other things in Git Kraken, we did do the basic material and we did do textures. Those work. So now that's working, we can actually stage these changes and submit them. So edit texture support. So edit support for textures, right? Next up, there is another card I want to make, and that is I want to improve the model structure. Improving model, right? So I want to be able to basically have one big model have one big model and be able to render or split that in submeshes. Right, so why do we want this? Well, basically, we need support for this if we want our model to have different textures or different materials. The same model, different materials. What is quite important, but for now, this is not that important. So this is currently in the backlog. And I don't think it should be that hard to do, but currently I'm just not interested in that because there are some bigger issues I want to do first. So, to come back to Visual Studio, right? If we run this in debug, in debug, right? If we look in the console, right, we can see how god-awful, how god-awfully long it takes to render the triangle, or sorry, to build the BVH. We can see like this is the BVH building in real time. I think this takes like 2 minutes, 3 minutes maybe. Anyway, way too long. So it takes me 3 minutes before I'm even able to debug. Once it's built, it's quite fast. I can render in a few FPS, more than enough to be debug, right? But it just takes too long to be able to debug. What is a problem? So there are 2 ways to improve this. One is simply storing the BVH so I can reload it. There are quite a few complications with this. I do think it's very doable, but this will be a longer process to achieve. The second thing you could do is speed up the BVH creation itself. So I did have an idea for this, right? So I have a job system. The job system is being used by the actual rendering, right? So this took, what is it? Go away, GeForce Experience. That PC. So this took about 1 minute and 15 seconds to build the BVH for the potato, and we can see once it's actually running, it's good enough to run it like 3 frames a second to 2 seconds per frame or something. Plenty to debug. I should turn this transform off as well. So the job system. I think we can actually use this for the BVH. So I had an idea, and if this works, building the BVH in multi-threaded systems would actually be very trivial to do. So what we're doing in the build BVH, right? Alright, subdivide. That was the one I was looking for. So we basically subdivide the left and the right nodes. So I was thinking, why don't we simply multi-thread this? So we make a job out of each subdivide. So that means each core will be able to get a subdivide. The only thing that is important is this part. Hey, welcome back, Mustafa. Welcome back. It's been a few days since you were last here. Right, so I'm still working on the Raytracer. I mean, well, the title says it, right? So let me show you what we've done since the last few streams. So we actually managed to get texture support going. So we can now actually render textures on models. And it's now actually running in a decent frame rate as well. I mean, it was already before, but that's actually running quite well. However, I think I made a small mistake. Or not, I was testing some things. And in the job system, I put this to 0, right? Let's put this back. So, yeah, no problem, man. It's the holiday season. Everybody's busy. I'm just glad you're here now. Right, so this line is very important to not fry my PC while it's rendering. So the stream actually gets some CPU power as well to actually not kill the stream. Right. So to come back what I wanted to say about the multi-threading the BVH, this is the only part that is important, right? Assigning the left and the right of the BVH, so setting up those variables, and that's dependent on the pull pointer. So this should be protected. However, I think that this part can be multi-threaded because they never should be touching the same data. The only data that's being shared is the pull pointer. but I think this is fine because it doesn't really matter where in the array everything is, as long as it is there. So if my suspicions are right, we should be able to multi-thread this, like with a few lines. So the first thing we would need is to include mutexes here. Let's include mutex, right? And then we need a std mutex m.lock, right? So then we would say lock m.lock and m.lock.unlock, right? So now, even if if multiple threads are trying to set this up, they have to wait, right? So the first thread comes here, it locks the mutex, then it does this and then unlocks it. If a second thread comes here, it sees a lock, oh, I'm trying to lock it, oh, but wait, it's already locked. Then it has to wait for it to be unlocked. It's basically waiting in a loop, right? And then once it finally unlocks, the next thread can pick it up and do the work. So then we would need to include the job system here. Hashtag include core/job system. And then we have job system, right, RT job system, job system.execute. Then we would need to pass in a lambda. No, sorry, I think we could just call subdivide. No, sorry, we do need the lambda. This and a counter, right? Do I need a counter? I'm thinking, right, because we do need a counter. However, I'm wondering if the current node has to wait for the children nodes to complete or not. I don't think so. So I think what we can simply do is have a counter here. So this would be, we need to include atomic as well. So I can include atomic. So we std atomic of type int, and this is m.counter. And then in here we would simply pass the counter. Where is it? Right. So m.counter, oh sorry, no, m.counter, and this is a pointer, so we need to give the memory address. So, and then this we call m. Right, and this is with a reference, right? The subdivide. It takes in a, yeah, it takes in as a reference. Yeah, I'm doing great, man. My Christmas was actually pretty, nothing that special. So Christmas Eve I celebrated at my dad's, and the rest of the Christmas I was just kind of chilling, streaming, just hanging out. Nothing too special. How was yours, man? Yeah, I mean, sometimes, honestly, I think that simply doing nothing is always good as well. But really? Ah, okay. Oh, yeah, I actually forgot about that. A lot of cultures don't celebrate Christmas. Not that it's bad, right? But I sometimes don't pay attention to those things. So, yeah, sorry. Or at least, not I don't pay attention to them. Sorry, that sounded a bit wrong. I should say you don't always realize that that's happening. I mean, in the Netherlands, Christmas is, I think, different than in America in the sense that most people celebrate Christmas. However, it's not nearly as big as in America. It's, yeah, how would I say it? It's more, we often do gifts, but it's more a social thing, getting together with your family, stuff like that, than rather the big, how big it is in Christmas in America. I would say it's like 20% of that, right, on the size. because we do actually kind of have a different holiday. Also in December. What's bigger? It's called I think English would be Saint Nicholas, what is basically an yeah. It's really hard to explain what it really is, but yeah, it's another celebration. It's quite similar to Christmas, but it isn't Christmas. No, I'm from neither, so... Hello there, yeah. Right, so, sorry, I was saying where I was from. No, my dad lives near Rotterdam, however, I myself live more in the southern provinces, so it's like an hour away from Rotterdam by car, right? However, I mean, everything is an hour away from Rotterdam in the Netherlands. Hello, Lyria. Thanks for joining the stream. How are you doing? Oh no, you still want the pink donuts? I will get them to you one day. I can only give you the I can give you the square pink donuts. My friend, right? So no, we're actually doing traditional ray tracing, so with the style ray tracing. So the what is it? I think it was the original paper was something like the 900 something. It's quite an old paper with its style ray tracing. So let me see the date of it, because I think the paper is very easy to find. Right, I say this, but I can't find it immediately. Right, anyway, oh, it helps if I type paper. Right, I don't remember, but it's quite an old technique, but I think it's also a very elegant and simple technique. And you get very nice results from it, even with doing very little things, right? So with path tracing, it takes quite long before you get nice results. But with it, you get quite nice results almost immediately. So, wait, let me run this real quick. I need to finish this up and then I can run it. So, job system dot wait m.counter. So this is something for multi-threading that I'm testing, so we might actually not be able to get an image, but I can see by running this. Okay, that was, I suppose, too much to ask for. The multi-threading just worked immediately. Right, let me put this back where it was, so I can actually show you what I was doing. I had hoped that the multi-threading would simply work, but yeah. Right. Ding, 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 ding. Right. So this should work. Right, yeah. So now we're getting the image back, right? So what I've actually been doing during the streams, so let me update you real quick, my strand. So basically what I've been doing is adding model support, texture support, and bounding volume hierarchies. So we can actually run render models in real time. So this is running currently at about 15 FPS. What still is a bit low, because I've seen this running yesterday at 30 FPS, the same model, but sure. Sometimes my PC is a bit flaky. But we're running this in reasonable FPS, and rendering multiple models is fine as well. The only thing I'm curious about is how we're suddenly dropping this much in frames, but that's fine. It's still running in a reasonable FPS. So the biggest issue I had with this current setup is the bounding volume hierarchy uses binning, what is a quite slow technique, or relatively speaking, right? So in debug, the BVH takes like 1 to 2 minutes to complete, like depending on how big the model is, before you can even start debugging the program, right? So that's quite painful. So I've been looking into how I can multi-thread the BVH, because if I can multi-thread the BVH, that would speed up the construction by a lot. I mean, that would speed it up by like, what is it, like 8-10 times maybe? No, a bit less, because anyway, it should speed up by quite a big margin. And I think we can do it relatively simple. So I've been trying to get that working. Oh, right, I think I see what's happening. Why we're actually getting the error before, right? So, we do pass in the counter, but this function leaves immediately after the job is done. However, we're passing the infos and the nodes in by reference. For the nodes, this is fine, since they're literally just references to a class member variable. However, the left info, these are local variables. So once this function leaves, that variable becomes invalid. Yeah, so Strand, that's actually a very good solution, and I talked about this a bit earlier before the stream. This is actually something I wanted to do as well. However, I actually want to do both, right? So my plan was to only build the BVH once, because most models, if you exclude animations, right, you only need to build the BVH once, and even if you transform it, stuff like that, the BVH still stays the same. So my plan was indeed to serialize it. However, when we do load in a model for the first time, we do need to build the BVH. So it's still, I think, worthwhile to multi-thread it. And if my theory is correct, it should be very simple to multi-thread it, because of the way it's set up. Or at least that is my hope. So that way we can get fast load-in times and fast construction times. But this should be fine, right? Qualify drop binding reference of type. Interesting. So could it be since this function? No, this function isn't considered const. What makes sense? So why can we not pass this in there? Right. So basically what I'm doing is binning, right? So for people that are not familiar with it, I am basically splitting each of the axes into n number of sections, and I'm basically testing all of them and then analyzing the best possible cost, right? So that is the cost function here. So that would be basically the surface area of the resulting nodes times the number of objects that would be in there. And if that cost is less than the cost... Right, sorry, let me explain this a bit better. So splitting has a cost, right? Because if you split, you would have to do more box intersections to get to your final shape. So if you eliminate a lot of objects, that could be worth it. However, if you eliminate very little, it could be that the cost of splitting is more than the benefit you gain from having less shapes. So this is basically a formula to determine when we actually stop splitting. So in my old Raytracer, I basically did a much naiver approach, with a simply, hey, take the largest axis. So if X is very big, just split that in half. That worked decently. However, I am already noticing a huge difference by using binning compared to the one. However, binning is much more expensive to calculate because, I mean, we're doing a lot more things. Qualify dropped in binding reference of type, blah, 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 blah. Interesting. Oh, wait, I'm passing in this. Right. You know, that's a problem, because I think if I pass in this, right, it doesn't take this by copy anymore. So I think this now refers to actually the left info. So I think if we do this, it should be fine. However, then it won't recognize the yeah. I do need this because otherwise we can't call the subdivide. However, what I could do, what's a bit cheeky, is simply make a copy here. Or, no, you know, I think we can simply solve this problem by, yeah, no, I think I can do this much simpler. So in the subdivide, we currently take this in as a reference. However, what if we just take it in as a copy? It isn't that big of a data structure because all it is a model reference, 2 uints, 32s, and a float. So I think we can simply copy that. I think that should not be a problem. And that way we don't deal with the fact that the data here in the subdivide becomes invalid after leaving the function. Right, that looks more promising. Maybe. Okay, maybe not. So what is it currently stuck on? Call stack. Right, so it's waiting for the subdivide to be completed. Yeah, because right, we're already adding so many jobs that it has to wait for the subdivide to be able to execute. Sure. Okay. What if we actually... I think we created a deadlock. That's not great. Right. That makes sense. So, what we're doing, right... Yeah, we actually created a deadlock. Okay. So, we're always going into the left first. What would mean that after, what is it, like the 256 jobs that we have queued, it has to wait for the other jobs to finish. However, we can't finish the jobs because we have to wait for the... yeah, so the functions are waiting for this to evaluate, right? So it basically gets stuck there. That is a shame. Thinking how we can improve this. Because it could simply increase the number of jobs in the system. However, that wouldn't really be a solution. That would more be a band-aid for a bigger problem. I could do... No, that still wouldn't fix it either. we could make one job out of this, but that wouldn't improve anything either, simply because then we're still doing it in serial with extra steps, because we would give one thread one thing to calculate, but then that has to wait for the next thing to kick off, and we're not really improving anything. So how do I want to do this? Because this is kind of a shame. Because we're basically, the issue is that we're dealing with recursion. I could use SCD async, but then we're kind of circumventing the job system, what I don't want, as then we're spawning, I think, more threads, and then we're getting job contention, and yeah, I'd rather not do that. Can we even do this? I think we should be able to. Right. Interesting. Because yeah, so in the job system, we can actually see that I think in here, we simply have it set up to, yeah, I have 256 jobs. So after 257, so at number 257, it will simply say, hey, I have to wait for the other jobs to be complete, but the other jobs can't be completed, because they have to wait for this line to evaluate. That is definitely a shame. I mean, I'm kind of curious what happens if I use STD async instead. Hashtag include async. Oh, but we still would have to wait for them to join, I think. Wouldn't really solve it either. So if I go to the job system, right, and increase this to like a big job pool, right, would this in theory work? Maybe. I mean, it does render. That I would definitely call that improvement. However, I don't know if this actually speeds things up or not. So if we put this to debug now, right, how long would this take to render? And do I see all the threads actually spike up? No. Do I, what happens in Task Manager? No, I don't see them either. Interesting. So why does it not use my entire CPU? Yeah, I know MSVC and debug is actually horrible in debug. It's so slow, especially with SCD, with like the standard library. It becomes way slower. Oh wait, let me. Yeah, so here we can see the CPU utilization, but it's not 100%. What is kind of interesting. I mean, you know what I could do? I could actually change the language to GCC, I think. If I go into the properties, property. Oh no, wrong window. Property, right. So I think I can in C++. I can set this to Clang. If I go to code generation, All properties. I remember there being an option for this. Language, right? I think it's here. I thought there was an option somewhere for it. Or is it in their general rule? Right, let me Google this real quick. Yeah, right, so it should be under General, Platform Toolsets. However, we don't have Clang. So, oh, if using Clang tool, yeah, no, just right, it seems I need to add Clang. So I think this would be in VCC directories. Then on this, so include directories, I think would be it's bin. So where do I need to add the Clang path? I mean, it might be worth it. I think it's very, very simple to set up. I have never done it though. Right. Let's see if it now recognizes Clang. So this is the I do need the 64-bit version. Because apparently Visual Studio should have Clang installed. Wait, there should be a macro. Interesting. This is like ships. I pulled this from like MSDN, this macro. So that's interesting. Oh, maybe I need to download something. No, actually, that's the funny thing. That works fine because I've worked on console development as well. They have used Clang as well. So debugging actually works great with Clang. Oh, right, okay, so I see. So I need to go to Tools, get Tools and Features. Right, so it's not showing this, but that's okay. Ah, yeah, no, I'm afraid I don't have that options. Right, so there should be desktop, Clang. And there should be Clang compiler somewhere. Why is it not showing up here? Right, so let me share this. Window capture, tools. Right, so now we can see that. So there is the Clang tools for Windows. However, there should also be a Clang compiler somewhere. However, I can't see that. I could still check out. Oh, they should be under optional. Could check this out, right? No, this doesn't seem like it. This doesn't look like it either. I could go to individual components and search for Clang. Yeah, sure. So modify. There's only 3 gigs. It should take a minute or so to download. Oh, right. I have to close Visual Studio. That's a shame. Retry. Oh, I still have the console window open. Right, retry. So this should take a minute. Yeah, look at it. Oh, I'm so happy with the new download speed. It's so much quicker. So I recently went up from 100 Mbps to 500 Mbps. What makes downloading everything... Nah, man, don't worry about it. I do roll myself all the time as well. So yeah. And if I actually get way better performance with Clang, that might be worth it. Although I still don't want to give up on the multi-threading. However, I'm not sure if I can actually do the multi-threading correctly, because we're dealing with recursion, what makes this a massive pain. And I don't think setting the job system to like a ridiculous high number would actually solve this issue. It would just be a band-aid, like I said before. That is kind of a shame. However, what we could do instead is multi-thread multiple BVHs. That is very trivial. However, I don't know. I think indeed serialization of the BVH would be a better option, actually. Right. Launch. Now, hopefully, we should have the Clang compiler. So if we now go into properties and go to general, there we go, Clang, apply. That wasn't that bad. Right, debug. Let's see this magic. I have faith in your Clang. If this doesn't work, I'm blaming myself and nobody else, because blaming you wouldn't really make sense. I mean, it took me a few minutes, so it's fine in it either way. If it speeds it, oh, that does look promising. Whoa. Okay. Either Clang is doing something magical here, or my code is suddenly doing something magical. Okay, so... Yeah, I know, right? So when we so my university, we first had a really shitty building because the new building was being built, right? So the internet was decent, but nothing too special, right? It was enough to work on projects. However, when the new building got completed, we were there and I plugged in the Ethernet cable, the setup right. I was like, curious, how fast is the internet, right? Because in high school, the internet was absolutely garbage, right? You were lucky if you could open YouTube. So I checked it out. I was like immediately 1 GB per second. I was like, oh, this is not bad. But yeah, sorry. Getting back on topic to the renderer, this difference is insane. This is actually like this is near release performance for well, I mean it's not near release performance because it's running quite a bit slower. However, compared to the MSVC compiler, this is like insanely better. Because this is taking like 10 seconds to build maybe, instead of like over a minute. Yeah, that's insane. But yeah, I really want 1 GB per second at home. However, it's not available here, or at least, I mean, it's available in the Netherlands, but not in my region. because my neighborhood isn't that like new, so 500 Mbps is the max I can get. But yeah, thank you for the tip for Clang. This difference is quite big. Right, but I don't think the job system can really solve this at the moment. So let's put this back to... Yeah, okay, that's true. I mean, I'm getting pretty close with 500 Mbps though. Wait, let me show you. Let me share my screen, my display, right. So if I do the speed test, right, I'm usually receiving about 450, I think, here. Or actually, yeah, we're reaching the 500 Mbps basically. Yeah, thanks, Jinx. Wait, really? Okay, that's actually pretty insane. That's awesome. But yeah, the download I'm reaching, I think upload, we have something like 40 or 50. I'm not too sure about the upload speed. I know it's way less than the download, but I'm not sure on the exact number. But yeah, I'm getting the speed that is advertised, so that's pretty cool. But yeah, so I do actually think that the serialization of the BVH is pretty smart. So the only thing I'm wondering and how I want to approach that, because I was thinking maybe create my own file structure, right? With that contains the model, contains the BVH, or it simply searches in the. I think a better solution would be when it loads in the model, it looks in that root directory for .bvh file in the same directory. So the next thing is how I would read in that file, because we're sorting in place the. So when we build the BVH, right, we sort the triangles in place. So I think one of the things we could do is give the triangles a index when they're created. So it's like triangle 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, blah, blah, etc. And we can simply use that to reconstruct the BVH quite quickly. Because we already know the bounds, stuff like that. We know what belongs where. So with the indexes, we can simply sort them in that order. I think that would be reasonable. So yeah, let's do that. So this was in model. That's right, triangle. Right, let me show you. So the triangles. Oh, okay, right. So they are stored in the models like this, right? So the model has model data, what is just an STD vector of triangles. However, each model got a shared pointer to this model data, right? So if we want to load in 10 potatoes, it would still have the same BVH and same triangle. So we're not duplicating memory there. Wait. What I could just do is, I just realized, right, I don't have to do anything sorting. I could literally just serialize the triangles and just overwrite the loaded in data from the obj. So what we could just simply do is load in the obj like normal, because we still want to read the materials and stuff. And then once it loaded it in, it checks, hey, do we have a BVH file? If so, read that and just overwrite all the triangle data from that file and create a BVH structure from that. Yeah, I think that could work. Yeah. I think that would be easy. So maybe I want to store this in JSON, because JSON might make things quite easy. However, I'm not very familiar with JSON. But there are some pretty good libraries in there. Or I could use a library potentially like Serial. So serialization. Right. So you have this this library, Serial, that helps you with serializing data. Because all I would really need to store is the triangles in an array and the right. That would actually be the most performant, yeah. A mem copy. Yeah, wait. No, actually, I have an idea, right, what we could do. You're indeed right. So we could create a small... let me open Paint, right? So let's say we have data, right? So we have a small header. This would contain how, like, a uint32 with, like, the... Yeah, that's true. So what we could do simply instead is have a small header that says, hey, we have 32, or we have n number of triangles. The and for I think the size in bytes of the structure. Then we would have as well in here offset bounds and number of bounds and size in bytes. So that way we can indeed simply do a mem copy in the triangles. We simply get the number of triangle size in bytes, do a mem copy over that region, and for the BVH we can do something similar, but this is well, this shouldn't be bounds, it should be the BVH, but whatever. So I think we could make this header, and this header we can just define ourselves and simply store it in a file. I think that would actually be an easy way, because the the only thing that I'm thinking, what if the triangle becomes bigger? Because what if we want to add say vertex coloring to the triangles, what we currently don't do? I mean, we could add this code quite simple, or I mean, we can simply use the size of a triangle in this code, so that is consistent. However, then some of the data would be garbage, but I think that is okay, because that that would be fine. Right, so you can check for the right. Okay, yeah. Okay, now that makes sense. So the magic number would be basically your file type, right? Because I remember image headers containing this magic number as well. So you could basically check, hey, is this actually the type of file I'm looking for? Yeah, and then the version, we could simply say, hey, we're on version 4.3 of this format. So if it's not 4.3, then remake it. Yeah, exactly, right. Right, no, I think we can make this work. Right, so what would be a good place to... Oh, let me remove paint. I suppose we could just simply add a serialize in here. So in the BVH we do a void serialize, and this would take in the RT model data, reference model, and that's it. It just needs the model. No, do I? Yeah, because we don't store it, right? Sorry. Ships, wait. No, it's not that easy to simply... No, this is fine. Sorry, what am I rumbling about? No, this is fine. So we want to first define the header. Define header. Oh, and this should be the file path. Oh no, I'm already feeling the pain there. Yeah, I mean, sometimes this takes way longer than it should. But yeah, there's right constellation for up. Right, so to do define header, so first we need to create a file. Create file, define header, to do define triangle, to do define Bvh data. Right, sure, some quick notes here. They don't make perfect sense, but I think they should be clear enough. So window C creates a binary file. So I have used some file before, however, I'm not an expert at this. So, right, so first of all, we need to create a file. So I think we simply use the file and then so this would be the file pointer f. So file, this is equal to f open. However, there is the new save, so this would be, what is the difference with the s and the, yeah, we can just live on the edge. I'm fine with that. So this would be file path plus, no, we need a bit more info here actually. So we would need file path and const std string reference model name. So this would be root there instead. Right. So root there. So this would be root there plus file model name. Oh no! I'm missing the. So there should be another const std string reference. Model name. And because you're on Windows, you're going to spend, yeah. So plus model name, and then this should be in brackets because we need a char pointer, right? And of course that doesn't work. Can we simply do this? So we construct the object. No, that was too much to ask for. File name, root there. Oh, base there. No. Base there plus model name. And then we could do this. Let's see, string. And then we pass in the mode, what I think would be write back. Yeah, I think that should be okay. So then we have the file. Yeah. Yeah, I'm having a Stack Overflow post here as well. So assert file does not equal no pointer. Then we want to, right, so now we have the file. Then we need to define the header. Do I want to create this? So one thing I'm actually curious about, right? I have never created a binary file, so do I want to store this just as numbers? I think I just want to basically store ASCII values, right? So I would have something like the format would be the file type would be 777, and then 888 for the version, or 134, then 1000 bytes, yada yada yada, right? I think this should be the format, right? And then you just interpret that data. Yeah. So let's define a struct. Yeah, let's define this in the CPP. Right. Oh, and X is the file type. Ah, okay, that's awesome. So if we have the struct header, and let's say just int X, int Y. So that's so we can do f write oh, we do need to create a header here then. Header test. So add test 1. Oh, no, sorry. So that would be size of test 1 file. Huh. Right. Okay, so oh. Okay, right. So then for the header, this would be literally all I have to do, right? To write the header. Yeah, okay, so then I would do fread header, basically. Or do I need to make one? Does it the fread move along, right? So after I have read the first part, does the next fread start from the ending there? If that makes sense, what I'm saying. Okay, that's awesome. That makes this so much easier. Right, then this will actually be 10 times easier than I expected it to be. So this would be file. Sorry, this would be program name. Program name, and this is equal to string to. Right, okay. But I don't think we need to do that. String to so this would be Bvh, and that would be right, this number, this would be, sure, we can do this. So 66 would be B V H, right? So this would be basically Bvh. UN32T version. I mean, for files, the C-way is sometimes the best. I mean, Iostream, I don't know, love-hate relationship with it. I do actually have more experience with using the C reading than the Iostream, I think. All right, 001, sure. Ooh, I have used Iostream a bit before, but it's still finicky. One of the things I actually miss quite hard is string matching from Iostream. So if you, I sometimes have the case, right, where I want to see how many floats a line contains, but there isn't really a way to do that in with Iostream that easily. But yeah, I don't know, Iostream has problems. UN32T, number of triangles, UN32T, size of triangle, UN32T, total triangle size in bytes. Right. I mean, we could collapse these values, right? So we technically don't need the number of triangles because the total size and the size of a triangle would still be able to figure that out. However, I think we can safely store extra UN32T. I mean, we're not running out of space these days, so just having the variable be ready without having any calculation, I think is nice to have. So that's those values. So then we want another UN32T, number of nodes, UN32T, size of node. Yeah, exactly. And I mean, we're not in the like 80s anymore when every byte counts, right? And total size of nodes. Okay, so that would be the header. So I want a header file header. So let's set up these values. So file header dot number of triangles equals model dot triangles dot size, file name file header dot number size of triangle equals size of model dot triangles dot 0. File header dot size of triangle size, that's right. This be total size of nodes equals file header number of triangles times, oh sorry, this should be total size of triangles, total size of triangle, no wait, triangle size in bytes, oh, node size right, this makes a bit more sense, times number of triangles, no times size of triangle, file header dot number of nodes equals m dot nodes dot size, and file header dot total size of nodes equals file header dot size size of node times file header dot number of nodes. Right, so one of the things here that you may actually notice, I've actually hard-coded this value, so the node is always 32 bytes. So the cool thing I can do with this, theoretically, is I can fit 2 nodes into one cache line. So that means I can do the left and right node in the same cache line without having to gather new ones. So that could theoretically speed up performance. Yeah. Right, and then we write file header and size of file size of header. Right. Cool. Create file. So something I'm curious with fopen, if the file already exists, what it does, because it's in write back mode, correct? If I'm correct. So what if the file already exists? Because then I'm thinking it creates another one. Yeah. Right. Because we would only do this serialization once, I'm guessing. However, no, because we would still need to see, even if the file exists, if it's the... No, when we load in the model, we would read the file, see the version number, and if not, we would reload it in. Sure. So we don't actually need to do checking here. Because if we call serialize, we know that the version is out of date. Or doesn't exist. So this doesn't have to take care of it at all. So this is a std vector of RT triangles. And a std vector of RT Bvh nodes. Yeah, sure. Do your thing, man. Yeah, thank you for the help, and thank you for joining in this stream as well. We'll probably be streaming for another few hours because I have to leave in about 3 hours to go to work. But thanks a lot for the help with the serialization. I've definitely learned some really useful things here because this makes my life like a million times better because this makes it so easy to save files. But yeah, thank you for joining the stream, man. Right, next up. So we want a body, file body. Yeah, I'm actually surprised. I thought this would be like way worse, right? Because this should technically almost work. But yeah, file body, size of, ooh. Right, I would need to do the file body here. Yeah, I mean, that's exactly the point, the idea of the BVH, right? So once you download the project from GitHub, you it would run once the BVH construction and then cache it locally. So next time it loads it in much faster. So it's perfect actually for that need. Because it could be theoretically quite a big file, right? So you don't want people to download it because they can just build it locally. However, you can't build an OBJ file because you need to download it. Right, I think we actually already combined this. Save body data. So when the load obj, obj loader, where did I build the? No, it's in the resource manager. So in here, do I? Yeah, I built the build bvh there. Sure. So there is actually something here that I want. I want the get base dir function and move this to a separate header, simple utility header, because I actually want to kind of use this on some more places. Utility.h. This would be a header file. So it includes string. Yeah, I think that should be everything. Then in the obj loader, we would get rid of this and hashtag include utility/utility.h, and then this would be RT, right? And then the resource manager, we can simply do the same. We want to test this dot serialize dot gets. Yeah, this is a bit messy. I should clean this up. Dots, and then I need the utility header here as well, the newly created one. Utility/utility.h, right? Get base dir of file path, and then test.bvh. So let's see what this does if I run it. Okay, that fills. And be Stone Egg, thank you for the follow, man. Oh, this is still complaining. Ah, right, that should fix it. I hope you're enjoying the stream. Why is it failing? No instance of... Right, where is this failing? Our duplicate symbol. Okay. Is in the utility.h. Okay, that succeeds now. Okay. Oh, you mean this basically, the what my mouse cursor is hovering over. if that's what you're talking about, that's Resharper. It's a really, really amazing extension. Yeah, it's Resharper. Let me link that in the chat. Right, so it's this. I think it's one of the best extensions for Visual Studio you can get. It is paid, however, if you're a student, you can get it for free. And there is a 30-day trial for it as well if you're interested. Right, so I wanted to show something. Where is it? I mean, I can just share my screen, sure. Screen, main display, there we go. So we can see that it created the file here. Okay, that is less great. It didn't actually right, so it's basically I'm not sure if you want to mix it, because Resharper and Visual Assist are basically the same thing, as in they both basically try to do the same thing, but they're different. So I don't know if you can mix them, I'm afraid. Oh, you know what I forgot to do? I forgot to close the file. So yeah, normally you would either pick one of the two. However, I can do a Google for you, and if you see if you could use them together. Visual Assist C++ with all right. Right, so they do have a comparison here between Resharper and Visual Assist X. I mean, it's a bit. I mean, it's in the favor of Resharper in this case because it's the Resharper comparison, right? It's from JetBrains themselves, the makers of them. However, it does give a bit of a comparison what you can do. So now the okay, yeah, there we go. So if we now look in the main display, right now we can see that we have something in here. However, this file looks way too tiny. This like actually looks way too tiny. Yeah. So, right. I think I maybe know why. Main display. Right, off again. So, what if it doesn't actually draw this? Because it's the SD vector. So, what if I do... I mean, I could do, instead of having a struct here specifically for it, what if I don't do body here, but instead, where did I have to serialize? Right, so I do f right, model dot triangles dot data, and say the size t is size of oh yeah, no, I think what we can do is still have the body here, but then this would be an arty triangle pointer. And same for the node. So then we would say f right. No, that still wouldn't work. Right. So this would be model dot triangles dot data, and it would be size of arty triangle. Arty triangle, and then element count is a number of triangles. And then we copy this, and we do m.nodes. And then this is 32. I could actually do size of bvh node, just to make our life easier. And this is number of nodes. So if I rerun this, do I gain a file that actually is bigger? Right, cool. Oh, this looks way better. Main display, like, look at this. That seems like a binary file. This is awesome. Right. That's cool. So now this is serialized. So we still want the body because we want to store things in here. When we read the file. Right. So this could actually be no, okay. Comment, right, this can be commented out. So I think that works. Then we want a read bvh. So void read bvh file read. Right, and this will be a boolean, and this will take in the same items, and it will see f open. Right, so we would do something similar here. So we would still get the f open, and this would be root dir. And this would be read back, and this would be fill to open file. And then we would do fclose file. Right. So we would have a header here. Header, this would be the comparison. So this would be major version. Header, this would be header check, right? Then we have another header that is red header, right? And this would be just default initialized. Then we do an f read add red header, comma 1. So it would be size of header, and this would be 1, and this would be file. So if red header dot version is less than header check dot header check dot version, then return then fclose file and return false. So this would be, hey, we read the file, but it's an old version, we don't support this. We would need to build the BVH again. So if that's not the case, we would simply say read body. So we would have a body, red body, and red body dot triangles equals fread. Oh no, I actually don't have to. So this would be at read body dot triangles dot red header dot size, total size of triangles, and 1. Oh, no, right. So this would be size of triangle right, sorry. So this would be size of triangle and red header dot number of triangles and file. So we do need to read body dot triangles equals new triangle, and this is red header dot total so number of triangles. Right, I don't have a default constructor. What is a... Oh, sorry, I could just... no, I don't need to do this. I can just do malloc. Malloc, and this is red header dot total size of triangles. Right. And red body dot nodes equals malloc red header dot total size of nodes. And we need to cast this to an RT triangle pointer and this to a node pointer. Right. This way we have now allocated memory. Then we would need to do another fread, and this would be nodes, and this would be size of node times number of nodes, right? And then we have this, so then we say model triangles data equals mem. Sorry, no, I just need to do a mem copy. Mem copy. So destination is model dot triangles dot data. Source is body red body dot triangles, and it's, how did I do mem copy? Let me double check mem copy. Right, so it's the I think it's count and then copy. So it's in C. No, I don't want to stop copying. Right. I mean, memcopy should just take a int value. Oh yeah, there isn't. Oh, it's memcopy that I need. Sorry, I think mem compare copy, what is wrong, and this is red header dot total size of triangles, right? And then we need another memcopy, and this is m.nodes. Right. We need m.nodes dot reserve red header dot number of nodes, and then we do a memcopy of m.nodes dot data red body dot nodes, and then red header dot size of total size of nodes should this be. Total size of nodes, right? So now we should be reading the triangles. We shouldn't have to reserve things here for the triangle data because already read ones. Right. And then this returns true. Return true. Right, so in the resource manager, this would say if dot read bvh file, and then we need to pass in the model, and then get base dir of file path, and test.bvh. Right, so if that is the case, or else so if that's false, we want to build the PVH. Oh no, wait, so models. Right, we want to assign this later, and then we want to serialize. And if this is the case, no, if we succeeded in this, we don't actually do anything because it's already done for us. So if this is false, then we want to do this. Right. Cool. So if I run this, no, chips. I mean, we can stop this, right? Stop, and I want to run this in debug. So let's see what this does. Right, so read bvh file. We go in here. Oh, go out. Go out. Right, so the root dir is asset/potato. Oh, okay. So file name, right. we would need another, we need a slash there. And same with the serialize. We need the plus there. Slash. Cool. And then the resource manager, we don't need this. Oh, I didn't click the button correctly. Sorry. Okay, so that runs. So now the file name. Wait. So the file name is now correctly this. So. Oh. Right. I just realized something. So if file equals no pointer, then return false. Because we don't actually want to assert here. We simply want to return. Right, so file's no pointer, so we return false. Okay. Then we should build the BVH. Right, come in here. Yeah, so then build and serialize. So now we should see the building. Right, then the potato is there, and I can now see a new file in my directory called test.bvh. Okay. Then we want to stop this and see this. So read bvh file. So we run this again. Build it right, and now we see that file exists, I think. Yeah. So now we do the fread, and red header is program name 66. Okay, cool. Version is 1. Number of triangles this. Size of. Oh, this is awesome. Right. Then we do the mem. That's a shame. Access writing violation. Oh. Oops. No, we resize space here. Because we... How is this running out? Oh, size of node is wrong. How is size of node wrong? So in the red header, oh, this is a problem. This is not actually the values that we want to read. This is completely wrong. Yeah, because it should be read binary, so that's fine. All right, let me rerun this. Right, so red header. Yeah, this makes sense, right? So how does this? So this, yeah, right. So red header is still fine. Okay. Right, so we just simply malloced. This is all garbage data. And this fills. Is red header suddenly... Huh? Okay. Okay. How does this get suddenly corrupted? Because we don't pass this in. Oh, wait a second. F3 takes this all in as... No, it takes this in a copy. Huh? Right. How does that get overwritten? So in here, right, red header should still be... Yeah, it's still good. Okay. Yeah, these values make sense. And it's now red header becomes garbage. But red body doesn't become garbage. Right? It might be. But that's impossible. Because it shouldn't have dependency on this anymore. What? This is very old. Yeah, and this will fail because, yeah, we're reading data that's pure garbage. But this is simply a mem copy. So sorry, the f read, right? It takes in, it does take in the file pointer, but how does the file pointer overwrite? Yeah. And this is even allowed to be const, right? So it's not like there's a dependency there. Oh, there's an... Oh, F... Yeah, I was gonna say that's... Why do you say this is allowed to be const? Okay. F-read corrupting variable. Right. So as I said before, right, the read header is completely fine here. But then after the first f-read, it becomes garbage. What the hell? That's so weird. That's so odd. How does that become garbage? Because we're never passing it in anywhere. Huh? I do realize something as well. Before we return here, we need to free body red body dot triangles and free void pointer red body dot nodes. Right, I don't do something weird with the malloc either, right? No, the malloc just it's just not read header either. And this is just like a size. What the? Okay. So the size of a triangle is 72 bytes. And you know what I want to actually want to do is delete the test BVH and take a look in the serialize function. Oh. Wait a second, right? So, no, that's correct. Oh. These are pointers. No, that's fine. I will still read the... So the file header, right, let me double check that. Yeah, that's this value. Right, so number of triangles is this, sure. And the file is that, and this is size of BVH node. And that's number of node, yeah. Number of nodes that we have. Yeah, sure. And it's there in the binary again. Okay. So then we stop this, and then we go to the read BVH file. Then we read this again. And it should still find the file, right? Because we created a new file. Yeah, the read header is completely good. And then it fills the second one. Because the read header gets massively corrupted again. Okay, right. This is very interesting. I'm going to go grab something to drink real quick while this is confusing the hell out of me. So I'll be back in a minute or so. Yeah, sorry for the wait. Right, I'm back. And I can put this away again. Cool. So I got my drink and I got something to snack on. So let me get some documentation open for fread. Right, so this actually returns its ST, okay. So this would be a size t return. Return, results, sorry. So results equals fread. If result, if that's false, then I want to do a debug break. Cool, let's see if that does anything. All right, what is the returns? Right, so apparently this is the number of bytes actually being read, the result. Interesting. I'm going to try something. So int num triangles equals red header dot number of triangles, and int size of t equals red header dot size of triangle. Right. So size of triangle is this, and num t is this. Right. Now we put a breakpoint here and see what this does. Now it crashes, right? Because reasons. Oh. Right, let's do it differently. So what can work as well is simply say right. So this is red header dot size total size of triangles, and we read one element, right? Let's see what that does. Okay, that crashes still. Very peculiar. Yeah. Interesting. I mean, there shouldn't be a problem. Because the sample code I'm reading here also does the f read in a loop. So I pass in a pointer, but that pointer is already, we already allocated memory for it, right? So that's not a problem. We simply say, hey, I want this number of bytes being allocated. Then I say, hey, I want to pass in this pointer, and then we want to keep reading, and we want to read header dot size of triangle, because that's that each element is this size, and there are red header dot number of triangles. There's not many triangles in the list. Like, you shouldn't change those values. But it's crashing now. Interesting. Yeah, so the file is valid. Red header is valid. But this is like actually the correct data. Because there are, yeah, about 27k triangles in the thing. So yeah. And this should be about fine as well. So this times this is that. I'm willing to believe that. So size of yeah. So why do you only read 56 bytes? Oh, you know what I could do? Is I could move result up, right? So result equals so what happens, what's the first result here? So result is equal to 1. Interesting. Is that the number? F read. So what does it return? Right, it's the number of elements successfully read. All right. And what is L size? Right. Right, so I can actually check for an error apparently. So if f error p file, sorry, so this should be file, and right, we can do a printf here, printf, oops. Yeah, that's cool. Why does that generate an F error? What the hell? Oh, yeah, there are no errors. Right. Because I'm guessing there is no error, sure. So why does it only succeed in reading 56 elements? Because its values again. No, thank you. I don't want to be rich. Don't spam me with the bad links. I think I'm even gonna delete this if I can. Can I moderation mod view? Right. I'm going to be deleting that message. And how do I delete somebody? Or delete a message? Right, block. He's blocked. Although I don't know how I delete the message. Can I give myself mod? Alright, I'm already a mod, cool. I can turn on auto mode, sure. Right, see if auto mode does something here, right. Okay, whatever. So, right, coming back to the issue, right? How does my header get wrecked? Because when I do the first f read, it is completely fine. It reads one element, the header result is perfect, nothing wrong there. But after the very first, or during the first read, the red header becomes garbage, like actual garbage. But these are just values, right? They're, once we do the first f read, we should. So I'm curious about something. So if I do, so what does, right, so if I say header check equals red header, right, and have this run, is the header check, is that also getting corrupted? I'm guessing not, right? So this is corrupted, but the header check is also corrupted. Okay. Huh. Right. Interesting. So this is fine now, right? I've already read it. So does this trigger? No. Okay. This is still valid. Header check is valid. It's the same, right? This is pure garbage because we haven't initialized it. It's just the value, right? Then we do this and red header is fine. Oh, sorry, this is just the malloc. Sorry. Yeah, and the malloc is not going to change anything because it's a malloc. It just takes in an element. However, this will mess it up. The red header suddenly becomes garbage, and so does the header check. But, right, maybe it's not garbage, but maybe it simply can't read it. Okay. Wait a second. I'm curious. So in the serialize, how do I... Right, I do 2 fwrites where I get the data of the triangles. Get our... Right, what if I do the following? Oh. Wait, what do I do the size of an arctic triangle? Sorry, that's the size of the size of. Then I do need to delete the BVH file and then put a breakpoint here. Right, so what is the size of triangle now? It's still 72. What's the exact same? Cool. 72 times, yeah. Sure. What if the f right here? No, we're simply saying, hey, I want the triangle.data. That is a pointer. No, but that's fine because that's... Then we write this. And we have this many triangles. Or 26,000. Then we do another f right. What is 32? Right. Times number of nodes. Sure. Okay. Continue, render, blah, 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 sure. Then we read it again. And I don't want this line anymore. Right. So the red header. Sure, these values all seem correct. So this is the malloc. We only read 56 elements. And then it failed. Right, so let me see the f read if there's any. So all right. F read access violation location, right? Sure. Oh. Wait a second. No, that should be fine. No, because we malloc a region of the total size of triangles, right? Weird idea. Like, what if we allocate this times like 30? Do I pass this? And same for this, right? What if we simply don't have enough memory to store it in? If there's something magically going wrong there. So what is the result now? It's 56. That's disappointing. And it's giving me exafilation. Yeah. Is that by any chance this? No. That would have been too much. Oh, should it be a pointer? Right. Ah. No, because then I'm allocating an array of pointers, but I don't want to do that. I want to allocate an array of triangles. No. Okay, very interesting. Right. I see maybe an issue. Okay. So what if I have something else? So I think we're reading the data simply wrong. I think I'm doing some bad pointer arithmetics. So I want to read an array of structures. No, I want to read an array. Right. So the example here is the following, right? So let me copy this into Visual Studio. So we have the following code, right? So int array, and we have we simply say I want to pass in array, because this is basically the same to a pointer. And then size of int, and then 5 elements, and then file, right? So instead I have a RT triangle pointer, triangles, sure, and let's malloc to this. Then remove the 30. Yeah, and at this we malloc. And if I do now size t, size equals size of triangles. I don't think it would do this, but I'm kind of curious. Right, so that size is 8, right? Because it's a pointer. Sure, that's completely fine. So we allocate memory for the triangles. Then I want to read triangles. Oh. There we go. Wait. I think I know what I did wrong. So this can still be this can be read body. Read body dot triangles equals that, but instead, right, I see what I'm doing wrong. I dereference this, but it shouldn't. I should do this. And now, because it's expecting a pointer, but it's already a pointer because the type is a pointer. So we're dereferencing the pointer giving garbage data, right? Now it's the correct value. Now we get this as well, right? That's perfect. So we now do memcopy. So now the triangles are all data. Cool. Fclose, free. Cool. And then go. That was to be expected. It can't work immediately, can it? So why is this not working? Oh. No, the normal is copied over as well. So why did this crash? So this container level, so the okay. But does a triangle intersect? Oh no, this is the Bvh intersect. Sorry. So this is complaining because of reasons. Oh. No, it should still be fine. Because we're just simply overriding the underlying vector data. Oh, however. Oh, is it the model data it's complaining about? No, this is okay. Oh. Right. So in the read, this shouldn't be reserved, this should be resize. Right, because we reserve data, we memcopy it in, so it's fine, but it doesn't realize we have a multiple nodes. Yeah, that's fucking huge. The Bvh is now done instantly. Oh my, that is awesome. So if we remove this file now, right, then we press debug. It should build the Bvh again in here. Yeah, cool, so it renders. Then we close this. We run it again, and then there should be instant. Pretty much. Yeah, because it can just read the... Oh, that's awesome. That's actually awesome. Cool. Sweet. I'm actually really happy with that. So now there's only one more thing to do, right? And this is now called test.bvh. However, we need the actual name. So we're already getting the file name. I think we can just simply get, like, there's probably some small function here. What the? Right, okay, I think in utility we can add another function. Will be an inline std string get file name, and this takes in a string. Right, and then we get this. This is stage 3 from Stack Overflow, hoop-de-doop, and that is string. Right, we do need to make a copy here actually. Yesterday string result, sorry, out, that's equal to string, and then this should be out, 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 and then return out. So then in the resource manager, instead of this, we do get file name, file path plus .bvh. Then we do the same here. Why is it still complaining? I expecting a... Did I have one too many? Yeah, I did. Okay. Then let's put a breakpoint in the utility. Out, and put a breakpoint there. Cool. Run. Out is potato. Perfect. Okay, run. Then it should build the BVH. It builds. Cool. We can close it. We can... I mean, we could... Nah, let's do debug again still, right? So then we reload it. And it's done. Instantly. Cool. That's awesome. That's actually really awesome. Cool. So now we can build the BVHs once and reload them. This was definitely worth the effort. So instead of it taking about 5 years to build the BVH, it's now done instantly. What I think is huge. Right. So now that we have done, let me check Github. So we have that open. Right. It's not actually a card here, but we can make a card. No, we don't actually have to because it's not sure. Let's go here, and in here, stage. So that's right, stage, and I think I want to stage every. Oh no, I don't want to upload the .bvh. Yeah, so I kind of need to set up a ignore. I think I can. There was an ignore here, right? Right, let me see it in Github how I set up an ignore file. Oh, there is actually a git ignore file. Okay. So there should be... yeah, there is literally a git ignore. Okay. So we edit that. Oh, no, we can actually do something better. So we can go here, ignore all extensions with the .bvh. Right, so now ignore and stop tracking, I think. Ignore and stop tracking. Cool. So now we don't add the Bvh files to GitHub. What's good, because the Bvh files are files that should be made locally, right? So now we say added Bvh serialization. So Bvh now serializes and is read upon model loading, speeding up the startup greatly. Right. And then we need to stage all changes and then commit. Cool. I do think I need to push as well. I think I've all, yeah, right, I see a big problem. So on GitHub, so I am not too used to actually using Git, so I mainly have been using Perforce. So I think what I've done, right, is I have actually made the changes, however, I've not pushed them to the depot. What is a problem-ish. So now I should have, yeah, now it's actually updated. Cool. And yeah, so if I go to my profile, can I see my activity now? Yeah, sure, I can see it. There are some more activity things here. Okay. Cool. That's sweet. So next up on the cards, let me see if any of you actually filled in. Can I leave moderating view? No, apparently not. Okay. Right, go to channel page. Right, that was the button I was looking for. So there is the Twitch pic, right? But it still has no votes, right? Okay, sure. So that means I suppose I can choose what I want to do. So if I go to the boards, what is in here? You know what I think would actually be good? To see if I can visualize the Bvh. And I think that could be possible quite easily. So in the Bvh, I want to try something. So I want to do a void draw Bvh. Draw Bvh, yeah. Generate implementation. And I do need to include OpenGL here. So I think that would be include glad. No, glfw. No, I think I had glad ready, right? So let me go to my graphics. Oh, right. So it's in # include graphics OpenGL glad, right? So I think there is a GL draw line. GL draw. Can I just do a simple draw line? OpenGL draw line. Okay. Right, so if I do GL begin, GL begin, mode GL lines, and then GL vertex 3D or 3f. So it would be m.nodes.0 dot bounce dot x bounce dot 0 dot x dot y dot z. Right, so this is one of the vertices, and then there is this needs a thing as well. GL draw vertex, and there should be bound 1, bound 2, bound 1, bound 1, bound 1, and then GL end. So if I now in trace, in trace, no, in the Raytracer, yeah. In here, I do model, no Google. So dot y dot model data dot bvh dot draw bvh. Okay, so if I do this, do I magically get a line in OpenGL? Maybe. Right, I actually just want to do this. So this should all be commented out. I want to see if I get a line. No. Right, so it is, it needs to be projected. Right. Right, so let me try a different thing. Right, so this can be commented out. I just want to see a line. I don't really care how it looks or what it does. I just want to see a line on the screen, right? And from there we can go to making the lines be correct. No, we still don't have a line. Oh, what if this is overwritten because this is done first and then it's being, yeah, okay, right. So in main, yeah, so we need to open main. So there's the GL draw. I'm somewhere doing the draw here. Yeah, window draw pixel buffer. No, yeah. Oh, cool. We're seeing a line now. Okay. That's awesome. Right. So we were seeing the lines, but it was overwritten by the background, by the ray traced image. Okay. So we need to do that at the very end. Okay. Cool. So in the BVH, yeah. So if I do this, and sorry, no, I do want this. I think this line width is about correct. And I kind of do like the red color, and then I uncomment this. Oh, recomment, sorry, uncomment. do I now get a line from one vertex of the potato to the other end? I mean, we're not going to see the potato because we commented that out. No. However, oh, what if the... Yeah, let's invert the Z, because OpenGL might be using a different Z. No? Okay. So, what are these values? Right, so this is -3. And this is -5. And this is 6, okay? Okay. Sure. Sure. So I simply want to draw a line. So if I do the old vertex, right, that was in here. And then I do put in the, right, so just double checking this draws. This draws the line we had before. Yeah, okay. So there's a line from 0 to 15. So if can I move my camera a bit back? So main, my camera is at 10. Let's move that back to 20. So do we see the end of the line? No. If I move my camera further back, so to like 500, do I see the end of the line? Or the line at all becoming smaller? No, okay. Right, so the line is infinite, what is kind of interesting. So if we do instead, okay, so if we do 2f, and then this is 0 and this is 0.5. Do we now get a line from the center of the screen to the other kind of part? Yeah, right, so this, right, it's in normalized device coordinates. That's a pain. So the same would be with this vertex, right? So if I do a vertex 3D, right, so if I do this, I still get the same line, I'm guessing. Yeah, I do. Okay. So we need to project the rays. Sorry, you need to yeah, project them to the plane. Okay, that's doable. Okay. So we would need the camera in here as well. Okay. So we would need the RT. So we need to define. Sorry, we need to forward declare struct camera. So it would need to pass in the a const camera reference cam, and then in the draw bvh would need this as well, and we would need to include the camera. Hashtag and then include camera. Hashtag include core / camera. Cool. So then we would do glm mod4 projection, and it equals cam dot. Does the camera have a projection matrix? It does have glm projection. Right, so how do I create the projection matrix? Projection project, right. So we would need the objects, the model projection. Oh, right, that's the position. Then the model. No, okay, so there is actually a projection function or project function, but I need the projection matrix. So would that simply be the camera, right? We have the glm look at. Oh, no, it's just the projection. Perspective. So is this also a type of projection matrix? This is a view matrix. Okay, this is something else. So for the camera, we would need a projection matrix as well. So glm med4 m.projection, right? And we would get a function, a const glm mod4 m. Sorry, this would be a reference. Get projection. Right. And then we would return m.projection. And this function is const. Okay. So then we would m.projection equals glm perspective, and we would say the FOV yeah, so that would be FOV aspect ratio is yeah, we already got that value, and then near and far plane would be, how would I calculate the near and far? So I would guess 0, 0, 0, comma 0. Wait, let me see the OpenGL projection planes. Projection. Right. So that is I think it's 0, 0, 0 and 0, 0, 1. No, so this would be 0 and 1. If I remember. Oh, and this would be, we don't need to cast this, we can do 0.f, sure. Cool, so that should give us a projection matrix. And now in the BVH, we can say, hey, cam.getProjection. Right, and then we say glm vec3 a is equal to projection times this. Oh, and glm vec3b. Oh, right, and this should be a come on, 1.f. Right, and then we can copy this line, and this is b, and that is bounds.1. Right, and then we want to glf, so this would be a.x, a.b, a.c, not b, sorry, what am I saying? X, y, and z, and this would be b.x, b.y, and b.z. And if we run this now, we should hopefully get the projected. Oh, right, no, sorry. We forgot to pass in the camera. So this needs the camera. And this is a const function. Because we're just wrong. Cool. Oh, oops, this should be m.activescene.activeCamera.get. All right. And it failed. Okay. All right, I don't think we set the yeah, I don't think we set the camera. So where do we set the cam? Oh, test scene dot active cam equals cam. So this needs to be a shared pointer of type camera, and it is cam, and it is equal to std make shared cam camera, and then this should be in there. Right. And as that, and then are we going to get errors? Probably. Yeah. So this would be .get. Let's see if this compiles. Yeah, sure, that compiles. Right. That was worth a shot. I had hoped for a... Oh, wait, the camera is still really far away. So let's put this back to 15. Because it could be projecting like very tiny, right? No, okay. But that still could be a sample problem. Sorry, A. Right. That's on minus Although there's actually a Glm Project Function. Glm Project. Yeah. And this takes in the object matrix. What is Glm identity? Glm for 1.f, sure. And then it takes in the model. Wait, what did I need for the projection matrix? There is the project. Project. Right, so what is the object? Right. Oh, that's a vec3, right? So that's the m.nodes.0.bounds.0. Then it's the model. What is a glm mod 4 of 1.f. Then the projection matrix. What is projection, and then viewport. What is, I think, the cam, right? And then we would need, in the camera, we would need another function. What would be a const glm mod 4 reference get view, and this is const, and this would return m.view, right? Then in the Bvh we would pass in cam.getView. There's the matrices. Oh, there's a tvec4. Okay. So what is the viewport then? Right. Let me see if I can find an example line. Original translate. Sure. Oh, okay. The viewport is the actual window size. Okay. So that would be 0.f, 0.f, 800. I think it's, I think that's my window size. Let me double check. Oh no, it's 800 by 800, 800 by 800. Right. And you of course do need to store that value. So, yeah. So that would be vec a, right? And then I don't need this line. Right, we uncomment this and then we check what the result is. And a is now equal to this value, sure. And okay, you know, I'm willing to perfectly believe this. Then I want to get this as well. And this would be bounds 1. Right, let's see what this does. I'd really hope this would have worked. Yes, this does draw a line, right? But it's not between 0 and 1. What's odd? Oh wait, if I do this, Does this generate me identity matrix? I think so. No. Okay. So we do definitely need the 1.f. Okay, cool. So the model is just random, sure. That's just a transform, but we don't deal with transforms yet because they're a bit finicky. So what is the projection matrix looking like? Oh. Right, so the projection matrix is this, okay. Sure. That definitely looks a bit weird to me. Right, let me go to the camera. And how did I do the... Right, so Glm perspective, it's the FOV, aspect ratio. Could I do infinity here? No, I don't think I could do that. Right. Anyway, I'm noticing my brain is becoming quite tired, and I think I'm going to call this stream here for today. I've been streaming for quite a long time now. I think like 2-3 hours or so. Let me double check. Right. So yeah, about just over 3 hours. I think we can call this stream here for today, so I can relax a bit before I go to work in an hour. And I thank you all very much for joining the stream, and have a nice day. See you all later.